Welcome back to Algebra 2. So our next part of this is to be able to solve logarithmic equations by a couple of the same methods. Our first method being we're going to look at, in this case we have the logarithm and we're going to convert it to an exponent to get the variable out of the weird places. And the second one is when both sides have the same base, the insides are equal, and so we solve the simpler equation. An example of that is being down here, because I have 2 log 2's, x equals 7. In our first case, in these cases we only see one logarithm, so we are going to do base to the exponent equals the answer. And when we do that, what we notice is that we do know 2 cubed. So then we have a Algebra 1 problem to solve. We're going to add 17 to both sides. We get 25. Dividing by 5, and x equals 5. Same type of thing here. We're going to do base to the exponent equals the answer. We know this. We're going to subtract 1. And divide by 3. And x in this case equals 8. So that's the first method. Second method, what I notice is I have natural log on both sides. So I am going to have the inside equal to the inside. I'm going to move the x's this way, so I'm going to subtract x here and add 7. That gives me 3x, and dividing by 3, x equals 4. It does not matter what the base is, as long as the base number is the same for both. There's another method when they're different. We have the inside equal to the inside. We are subtracting x. And I'm going to add 10. I like doing both of those at the same time. We get 6 equals 2x, dividing by 2, and x is 3. Now they will get a little bit more complicated. We happen to have 2 different logarithms going on here. So I have 3 terms. That's probably the clue. I have 3 terms instead of 2. So I cannot get a log by itself completely. So what I do is I use the rules, and addition is multiplication. So I'm going to do log, and if I don't see the base, it's 10, of 2x, and I'm going to put everything inside parentheses here. Okay, so all I did was combine the 2 terms here. Addition is multiplication. Those 2 things are multiplied. And inside the log, I have 2x squared minus 10x. What's the base on this guy? It's important that I know the base, because the equation that I'm going to use is base to the exponent equals what's on inside. And in this particular case, I'm going to move everything to one side of the problem. So 0 equals And how can I solve that? All of your methods of solving quadratic formula. I'm going to divide everything by 2. Factors of 50, negative 50, that add to give me negative 5. And what I have is negative 10 and positive 5. Once I have them factored, the solutions change the sign when I take them out, 10 and negative 5. Okay, there's our steps. General process. We're going back to all the things that we've been able to solve. Now, when we do solve some of these, what we do have to look for is sometimes the solution isn't exactly real. So we're going to plug in. We're going to move the 2 to the other side, move the 4 to the other side, and I should have x equals 3. So by testing to see if I have an extraneous solution, what I want to do is plug it back into the original equation. 7 times 3 minus 4, and 2 times 3 plus 11. Okay, plug it in, simplify to number crunch. I have 21 here minus 4, so that's going to give me 17. So I have ln of 17. And here I also have 17. Since both of them work out, it is a solution. 2 to the 5th power. This is the first method, x minus 6. This is 25. Adding 6. So I have 31. So in this case, when I plug it in, log 2 to the 6. And does that equal 5? And that would be a calculator number crunchy problem. How do I do log base 2 though? So this is log base 2 of 25 equals 5. Log base, answer exponent 2 to the 5th power equals 25. So that checks out as a solution. Okay, a couple more that we need to combine together into one problem. We're going to combine like terms. We are going to combine inside one log by using parentheses. And this is log base 10, so it is 10 squared equals, and when we multiply these out, we get 5x squared minus 5x. So we're going to move the 10 to the other side, and 10 squared, so that's 100. Okay, I'm going to factor out at 5 because we can. And this is factorable. Factors are going to be negative 5 and positive 4. So my solutions should be 5 and negative 4. But now we need to test those things. Do the log of 25. So that happens to be log base 10, so we can just do log of 25 and log of 4. And what we end up getting for log of 25 is 1.40, And for log of 4, we get 0.60. And those two do actually equal 2. Next, we're going to set this up to test for -4. So we're going to do the log. When we plug in a -4, we get -20. And when we plug in -4 on the next one, we get -5. And then when you grab your calculator to see if that works, we get no solution. So there is no solution for log at -20. It is out of the range, so that is not a solution. Okay, let's put these two things together. We are going to get log base 4 of x plus 12 times x equals 3. So 4 cubed equals, multiplying these out, x squared plus 12x. This is 64, so we end up with x squared plus 12, x minus 64. Factors of 64 that add to give us 12, that is going to be 16. 16 has to be positive here, and -4. So our solutions should be -16 and +4. Now when we test those in the original problem, we're going to have log base 4 of -16 plus 12 is -4. There's our problem. Plus log base 4 of -16. Okay, check it in the calculator. What you're going to find is, now I do have to do change base formula, but log of -4 does not exist. So I can't divide that by log 4. So these two terms do not exist. That means this 4 when I plug it in. Okay, that's going to be 16, positive number, and log base 4 of 4. So those ones will actually exist to give us a solution. So this one does not work. It is called an extraneous answer. Please show me the work. Show me the steps of substituting it in. Okay, that is what we are doing. Your assignment will be in Google Classroom. You will have some odd problems again to do so that you can check your work and see how you are doing. And have a good day.